Hello, my name is Professor Gabriel Kabanda. It's my great pleasure to be presenting this paper on performance of machine learning and big data analytics paradigms as they are used in cybersecurity and also in cloud computing setup. It is really quite a great pleasure for me to be sharing this research paper as a keynote paper for us to see and see the future as we look at these things in terms of technology. This particular paper is a paper that equips our future and in making sure that we have got very secure cybersecurity systems by making use of artificial intelligence methods, in particular with regards to machine learning. The paper looks at cybersecurity, and cybersecurity is, in this particular paper is considered essentially as a combination of technologies, processes and operations that we may use in a computer setup so that we minimize the damage or any cyber attacks or unauthorized access. The research paper makes use of the pragmatism paradigm, which combines both qualitative and quantitative methods of research. As we use these kind of approaches, we find that in a normal corporate environment, it's not complete to talk of normal operations unless we also discuss cloud computing. So cloud computing is therefore provided and also taken care of in this particular paper as a way of making sure that we make use of big data analytics models, as well as advanced methods of detection and prediction against any cyber attacks we may get. By way of introduction, it's important to talk about cybersecurity trends. Cybersecurity is the practice of protecting systems, networks, data from and any other programs from any malicious digital attacks. You can look at it as a combination of policies, techniques, and technologies and processes that are purposed to preserve the confidentiality, integrity, and availability of computer software and programs. It is therefore characterized by phishing and social engineering, which is the practice of sending fraudulent emails that resemble emails from reputable sources. There's also increasingly ransomware, where malicious software is used to extort money by blocking access to files or computer programs until the ransom is paid. However, the Internet of Things increases also the susceptibility or vulnerability of these computer systems, because in Internet of Things, we are adding gadgets onto the network with IP addresses, and the level of vulnerability is unknown, and it gets more and more complex. And this is why we then get worried of the third-party vulnerabilities associated with the use of this kind of technology. So we have to take care of internal attacks. We have to take care of also third-party attacks. The cybersecurity system, from a network intrusion perspective and prevention, consists of three elements. It has the user interface that links us to the user on a network. And then at the center, there is an analyzer or the engine, which computes and takes care of the data mining methods. It takes care of ways of checking the level of intrusion and what to do with that level of intrusion. And then thirdly, there are sensors that provide input from different sources so that we are able to tell what's happening in the network, what's getting into the network, what kind of packets and files are being accessed on the network. As you use a cybersecurity system, our main attention is on cybersecurity risk management, which is really a way in which we are assessing and addressing the vulnerabilities that are associated with cyber attacks, vulnerabilities on the networks, the computers, the programs, and other devices that are connected to the network. To manage this kind of systems in a better way these days, we have to make use of artificial intelligence methods, because artificial intelligence is all about using systems that can search, react, respond, adapt appropriately as you look at many things. But in particular, machine learning is used, which involves the use of algorithms or methods that enable us to do automatic data analysis, as well as ways of picking up the interrelationships among the values of data. In the discussion of this paper, we will pay particular attention on one aspect of machine learning, which is deep learning, which we'll talk about a little bit later on. What is machine learning? Machine learning is a process of instructing computers to learn. computers learn from the data that is provided in them in the same way as we understand the configuration set up in an artificial neural network. Machine learning is an automatic analysis of large data sets and was ways of producing models of the general relationships among the data that we look at. In machine learning, we see three classes or categories that are used in most setups. The first one is supervised learning. Supervised learning is one where we make use of inputs that are labeled together with corresponding outputs. Then in unsupervised learning, the inputs are given, and labeled inputs are given to the methods. And in reinforcement learning, the data is used in the form of sequences or actions, observations, and the rewards as we use them. The data environment that we operate is easily understood when we take the perspective of big data analytics. Big data analytics is emerged as a discipline or a way which enables us to analyze, do data mining or extract patterns and trends that are hidden, and even hidden meanings that are in the data that is inherent in the systems we're looking at. This is an area that has evolved from the traditional relational database systems we have used over the years, because we now have a lot of unstructured data, heterogeneous data from different sources, including social media, and this is increasing the kind of complexity of the kind of data we analyze and use, and the impact it has on the security of the systems that we're looking at. The Internet of Things also comes in as another dimension that makes us aware of the increasing complexity as we add more and more gadgets on the internet. And in a practical environment, cloud computing is a setup where we are getting services from different organizations all over the world. So big data analytics in itself offers a variety of security dimensions for network traffic management, access patterns, configuration of network patterns, as well as also ways of understanding the data sources that we use in a network. The statement of the problem arises from an appreciation of the phenomenal growth of the use of internet-based technologies, where organizations are constantly being subjected to cyber attacks. The firewall protection which we have known over the years has proved to be grossly inadequate because of the limitations against its external threats. So the main focus, therefore, is to look at network-centric cyber attacks, which are carried out by intelligence agents. And therefore, there's need then to be looking at ways of combating these through intelligent, semi-autonomous agents, which are capable of detecting, evaluating, and responding to cyber attacks as soon as they occur. And this is why this particular paper focuses on evaluating machine learning and big data analytics paradigms for use in cybersecurity, as well as also cloud computing environments. The main objectives of this research was to evaluate machine learning and big data analytics, and also to ascertain the impact of machine learning and big data paradigms on an environment that has got cybersecurity systems. The research questions were derived from the main objectives, and they are very much related to the objectives. By way of literature, it's important to understand the background that in machine learning, the classical environment in machine learning is characterized by an appreciation of basic algorithms, such as the logistic regression algorithm, which makes use of series of zeros and ones. Then there is the naive Bayes algorithm or method, which assumes independence of the features of the dimensions that is one handling it. There are also decision trees, which can be structured more or less like flowcharts, more or less like, similar to an ordinary tree with the branches that go down. The K nearest to neighbor algorithm is a common algorithm, which is non-parametric, and it uses similarity measures of distance functions that are computed. There is the ADA boost algorithm, which boosts the performance of simple learning algorithms as you deal with the classification problems. Random forest is another machine learning algorithm, which is similar to a decision tree, but in this case now it improves and brings better predictions than an individual decision tree. The support vector machine is the most commonly used and the most efficient machine learning algorithm, which is used in solving classification and regression problems. And it really operated along the lines of supervised machine learning. The modern machine learning is easily understood by looking at taking classical machine learning algorithms, but using then inputs, raw inputs, and also learning what comes out of those kind of inputs by optimizing the features that are given into it implicitly. And so here in deep neural networks, we make use of computational models which resemble biological neural networks. Other ideas from feed-forward mechanisms, the recurrent neural networks, linear regression, k-nearest neighbors, support vector machines, and so on are all combined. So we see these days now deep neural networks coming in as the main focus and growth pattern of machine learning, where we use not only classical machine learning algorithms, but also add others to make sure then that we understand the deep features of the data we are handling. From a big data analytics perspective, we have to start off from a simple context based on a situational analysis where we gather data, pick it up, make decisions through interfaces in different ways, and then take action or look at ways in which we assess the performance and capabilities that we get from these systems in that way. The operating environment or practical setup we have in the corporate environment uses cloud computing, which is all about providing internet access to someone else, using someone else's software running on someone else's hardware. There are 5 essential characteristics of cloud computing. And these are, number one, there is on-demand self-service, where services are unilaterally provisioned over the network on a given period of time. Then number two, there is broad network access, which makes use of heterogeneous client platforms that are made available to different capabilities, depending on what the clients and the customers do want. Number three, there's resource pooling, where you are able to pool resources from different tenants, different angles, so that a combination of what a client really requires is then given. Number four, there is rapid elasticity, which is a way of providing unlimited capabilities, where services are rapidly and elastically provisioned as and when they are required by the organization. And then number five, we have measured service, where a metering kind of capability is provided to control access depending on what the client or customer has paid for. So these essential services, 5 of them as they are, enable an organization or an individual to be able to access software as a service or platform as a service and infrastructure as a service. These 3 services are the major types of service that an organization or individual may be getting through a cloud computing platform. The way these services are provided is now distributed at the doorstep or in the community through a public, private, hybrid, or community kind of model. So this is why you find now with software as a service, one is able to get or able to provide applications that can run on an infrastructure. Platform as a service, third-party applications are provided in operating systems that come with it. And the infrastructure as a service is where the hardware, the network storage, and other hardware-related issues, the telecommunication facilities are made available to the organizations that require computing services. Cloud computing naturally has tremendous benefits. Some of these benefits include free capital expenditure, accessibility from anywhere at any time, no maintenance headaches, improved control, it's dynamically provisioned and is device independent. However, there are weaknesses and challenges because cloud computing requires a constant internet access and doesn't work well with low speed connections. It is normally very slow on desktop software. Features may be limited to some extent. There are always challenges of privacy, security, and availability as we look at them. But however, the benefits of cloud computing outweigh the weaknesses and the challenges. The way to improve cloud computing these days is to make use of function virtualization. Visualization is a way of designing and making use of the telecommunications facility so that we can create a visual image of the services, the operating systems, various applications put together and all viewed from a simple dashboard so that we get an increased return on investment on whatever a consumer or customer is looking for. Yes, visualization may have its own drawbacks, but you're able to see what's happening in different systems, different organizations, and different departments in a big kind of setup. The research methodology that was used in this research is guided by the pragmatism paradigm, a philosophy that makes use of mixed methods. Mixed methods is a combination of both the methods that we know as qualitative methods and quantitative methods. And in this research, both qualitative methods were used. In the qualitative method, focus group discussions were used to pick up and study and understand the environment by talking to executives in banking institutions to understand the limitations of the cybersecurity systems and so on. Then on the quantitative side, a descriptive research design was used, an experiment was done, models were created in order to test the performance and analyze the performance of various selected machine learning algorithms. And the big data analytics dimension then also was handled in such a manner that one is able to see and appreciate from the understanding of big data itself, how we make use of data mining methods and algorithms so that we then can be able to receive the kind of malware or intrusion detection techniques that are in the systems or networks that we are trying to access. Insights and predictive analytics then were derived from this kind of approach. The data analysis shows clearly that machine learning algorithms are dominated by understanding of some of the classical algorithms, such as genetic algorithms, which can give you good solutions. Artificial neural networks, which adapts automatically to the training as the data grows. The naive Bayes classifier, which is simple and easy to use. Decision trees, which can be represented by flowcharts, which are easy to implement, and the K-mean algorithms, which is also easy to understand and easy to implement, and is very, very effective in solving clustering problems. The cybersecurity system can be structured into two main categories. There is the anomaly-based signatures, as well as signature-based systems. The signature-based systems are the ones that make use of or are known to have low false positive rates. They don't require much in terms of training as we make use of them, but they have got wonderful features of classified arrays. Anomaly-based systems in cybersecurity are those that can detect new attacks and automatically do self-learning as we make use of them. So a cybersecurity system can be built by considering both aspects of both legs, and is more powerful in machine learning approaches to combine both signature-based as well as picking the best from anomaly-based kind of systems. The machine learning algorithms that were tested include the regression trees. And the regression tree is one whose accuracy and performance declines as we get more nodes, as we increase the complexity parameters around the environment we're in. Support vector machine, which is quite efficient, the accuracy increases, phenomenally increases, in a linear fashion as the number of nodes increases, as we get more and more data, as the network grows in size. Support vector machines perform in large networks generally, especially after the level of 0.5. Linear discriminant methods operate in the same way as the performance is similar to that of the k-nearest neighbor, whose performance is quite superb and increases linearly as we get more neighbors. Even from small networks going to large networks, the accuracy improves and gets better as was seen to there. Random forest has a performance which operates conversely from the k-nearest neighbor, in the sense that it improves and is good for small nodes and small networks. But once the network grows in size and you've got more nodes, there's more data, then it begins to decline in performance. So when there's an overload of data, random forest performance goes down. All these machine learning algorithms then can be structured and be made use of in an environment where we are handling large volumes of data, and you can put this in a model which has got modules with interfaces to various libraries and tools that enable one to do some queries, to be able to come up with the ways of balancing and putting up certain interfaces with different software environments that are required. So there's a lot of flexibility in building up a big data analytics model because of the software engine interfacing capabilities that are there, so that you can make use of each of those algorithms to understand what is there. And then in the end, you can build a cybersecurity system that makes things make sense. The machine learning algorithms, as you see them with supervised learning, it's an approach that enables one to come up with a predictive model. And this predictive model can be able to show clearly the relationships and the linear regression in particular, or the variables that one is looking at from time to time. You are able to estimate the value of Y for a given value of X. In reinforcement learning, we are interrogating both the environment and the agents, and it's a system and approach in which we are using machine learning in such a manner that we improve the performance of the system as we also check what is the environment. So the agent is linked to the environment in a reciprocal manner. And the interaction between the two continues to go on from time to time, as you often do. For example, one is playing the game of chess when two people are playing chess. Unsupervised learning makes use of, or extracts the data in such a manner that one can do some clustering of this data. And the main focus in this case in terms of applications is on coming up with clusters of data, looking at the distance functions among them, and understanding the dimensionality of the clusters of the data that we have in our environment. So in conclusion, we see in this paper that we can improve machine learning or improve, in fact, the cybersecurity system by making use of machine learning. Because the machine learning itself is as we understand it, it's a special part, aspect of artificial intelligence, where we can make use of supervised, unsupervised, semi-supervised, or reinforcement learning methods, so that the systems and networks can learn on their own the kind of intrusion that goes on. And this is what then enables us to come up with better cybersecurity systems, which do not require much of manual intervention. The system can be able to detect, take appropriate action, and minimize any further loss or damage to the system or any particular threats that is particularly going on. Machine learning enables us to do automatic data analysis and produce large, or come up with models that explain the interrelationships among the data. Big data analytics has become important. And even in future research, we have to make use of big data analytics dimensions and paradigms, because the environment we are working on is increasingly getting more complex. We are dealing with heterogeneous sources with a lot of unstructured data. And so we have to make use of big data analytics from the big data perspective, as well as machine learning, so that we get the best out of artificial intelligence, so that the systems, in particular cybersecurity systems that we use, then continue to become very, very secure and get better, so that we manage the cyber attacks, the threats, and any particular thefts that can take place, or cyber crimes that may happen on our networks. So this is what this paper was all about, and it agrees with a lot of literature on how one can combine both big data analytics models together with cybersecurity to build a better future for our organizations. The future for organizations is investing in the technology of machine learning and cybersecurity, so that we manage the threats that occur as and when we are able to get this kind of threats. And so this particular paper is a paper, as we look at it, that enables us also to guide us to develop specific cybersecurity models. In what some of the researches I've done in the past, I've developed specific cybersecurity models based on Bayesian network models. There are different models, but this is one of the approaches that can be done. We can construct, develop, and put in place very secure cybersecurity systems for the future. And so it has been a great pleasure for me to present this paper. And I want to thank you so much for listening, and I hope you've learned something out of this presentation. I hope also that if you've got any questions, we can be able to interact and further and take it up,